In this video, we'll review the notion of eigenvector and eigenvalue for a square matrix by way of an example. I'm going to let A be the 3 by 3 matrix that's presented here. The question I want to answer is whether or not this vector x, which is equal to 1, 1, 1, is an eigenvector of my matrix A. Recall that a vector is an eigenvector if when you multiply A times x, it's the same as scaling the vector x by some constant lambda, which we call an eigenvalue. So the question becomes, does A times x equal lambda times x for some constant lambda in the real numbers? All we can do is try to multiply A times x and see what we get. So we'll take A times x. I'll take my matrix A and multiply it by the vector x. When we do that, we'll get a new 3 by 1 vector, and that will be 2, 0, and 4. The question is whether or not that vector is a scalar multiple of my original vector x, which is 1, 1, 1. So is there a number lambda here that I can put to make these two expressions equal to each other? And you very quickly realize that that is not possible in this case. If I was to get a 2 here, I must have taken lambda to be 2. 2 times 1 would give me that 2. However, with lambda equal to 2, I would get a 2 in the second entry, and I don't have one. I have a 0 here. So it's not possible to make these two expressions equal to each other. They're not equal for all real numbers, lambda. The conclusion, therefore, is that x is not an eigenvector of my matrix A. Let's try a different vector. Let's ask whether or not this vector x, which is equal to 2, 1, 2, is an eigenvector of A. So let's try. We'll take A times x, multiply them together, carry out the computation, you get 4, 2, 4. And the question is whether or not this is a multiple of my original vector x. So is there a lambda here that when I multiply my original 2, 1, 2 by lambda, it gives me the vector that I get as a result from matrix multiplication with A, 4, 2, 4. And it's pretty easy to see here that if I take lambda to be equal to 2, I'll double that and get 4. I'll get 2 in the second entry, and I'll get 4 in the third entry. So in fact, if I replace lambda with the value of 2, yes, there is a real number that when I multiply x by that is the same thing as multiplying x by A. And so the conclusion here is that x equal to this vector that I started with, x is an eigenvector of A, and the corresponding eigenvalue is lambda equal to 2. Finally, just to reinforce a basic idea, is x equal to 0 an eigenvector of A? And the answer is always no. Eigenvectors by definition are non-zero vectors. We never allow the zero vector to be an eigenvector of a matrix.